Last week we learned about solving equations. So we came up with two strategies for this. We said there's one strategy that you're able to cross multiply, or the other strategy was called common denominator drop. Okay, so which strategy are we picking for this one? Cross multiply or common denominator? Which one? Cross multiply. Okay, so this times this will be the same as that times that. So make sure you treat things individually or families. So individual 4 times family at 1 plus x equals individual 2 times family 2x minus 3. Okay, distribute would be your next move. Please make sure if you have 2 binomials, your distribution includes a whole FOIL system, right? This was just a monomial times a binomial, so you just distribute. So our algebra from last unit, when we keep going back to that, is some kind of isolation. So can you get your x's on one side, your numbers onto the other side? I need you to have some kind of number on one side and some kind of x amount on the other side. Okay, so if I'm collecting terms together, this is what I ended up with. Did you get that as a number on one side and x is on the other side? So to get x alone, I'd have to divide. This is weird. What am I going to write? So tell me like this. 0 times what will get me to 10? Nothing. So then I'm going to write no solution. Nothing ends up working in that equation. Right? Can't divide by 0. Okay, and then the next one here. Okay, do you notice how the number 2? Look at, I made it look different. It's 2 over 1. That's okay, right? Yeah. I highly suggest that so our brains can just keep functioning everything as a fraction. So your next decision is, should I cross multiply or common denominator drop?
Common denominator.
Common denominator, so I need you to give me a fraction on each side. Okay, we have to think of a bottom that is commonly divisible by 3x, by 2x, and by 4. And I don't want to go bigger than I have to go. So between something like a 2 and a 6, I'm not going to make that 12 or 24 or something too crazy. What is the lowest thing I can think of that is divisible by all of those? What do we think? No, I want something that is divisible by those things. I don't want to divide these things by something. 12x.
I thought you said we didn't want to do 12x.
Basically, with partition transition.
No, I was giving a separate example when I said that.
Oh, okay. That's why I was trying to go.
I was using like a 2 and a 6, and that was just a random example. Okay, so look at it. Can you divide 12x by 3x? That works. Divide it by 2x, that would work. Dividing it by 4, that works. Okay, here we go. Changers. First fraction had the 4. So, what are we changing by? Look at 3x to 12x. What did you change by? 4. So change the top by 4. Next fraction had a 1, now a 12x. Therefore, I've changed by 12x. Okay, make sure at this point you move to the other side, right? Keep sides separate. 2x, how did we change it? We changed it by 6, so now we have 18. And over here we had a 4 underneath, and now we have a 12x underneath, so that got changed by 3x. Thank you very much. Okay, what did I do here? Well, mathematically, if the left side equals the right side, and then the bottom on this equals the bottom of that, I'm just saying, hey, well, just now the tops just have to be equal. Okay, go ahead. Isolation means gather, move, divide, whatever you have to do to get something alone, right? And I would leave it as a fraction. So leave it as a fraction. You don't have to round anything. You don't even really need to use your calculator then.
During the hall,
Will be.
Oh, not yet?
No. Okay. Just question 1 today. You have a solution of 20-liter antifreeze and water. Do we understand what a solution is? Do you know what a solution is? This is a solution. Why is it a solution? Because I've mixed 2 things together. Okay, I had powder in here and water in here, so it makes a solution. Okay. So right now, there's 20 liters inside a jug. 20 liters inside a jug. It has antifreeze and water in it. It has both things in it. Okay, so there's a mixture in there. Right now, it's 40% strength. Okay, so 40% of that fluid is got antifreeze in it, right? How do I figure out and work with percents of something? What should I do? And as soon as I see percent of something? Decimal. And what kind of operation? Multiply. Okay, so in that 20 liters, times something by 0.4 gives us 8 liters of antifreeze. Does that make sense to you? 8 out of the 20 is the antifreeze. Does that seem 40? Because I know 10 out of the 20 would be exactly a 50% ratio, right? Okay. We want to increase the strength. So how do you increase the strength of it? What should I do? Add more antifreeze. We'll make it stronger, right? So I'm going to add more antifreeze. What happens to my jug if I add antifreeze? The jug will also fill up more, right? Okay, now when you have a test, how do you determine your percent? What do you do in a test? How would you say, oh, I got this on the test? Based on? You would take how much you score out of? Total. Okay, so here we go. We started with 8 antifreeze liters, right? And then we did what? Added more. Out of total. So what was our starting total? 20. But then that fluid also increased a little bit too, right? So what I'm really doing is antifreeze divided by total, by fluid. And the result I want to get to is 60%. Okay, we can write this numerous ways, but I just always say out of 100, because percent out of 100. You can write it as 6/10 if you want, you could write it as 0.6, but if we just do out of 100, it's always the same format, right? Okay, I'm done. You know how to solve this. What do? Cross multiply, I heard, that's true. So this times this.
Yes, I do, because there's,
Okay, the rest is grade 10, distribute, collect, right? So go for it. You got it on your own. Distribute it, collect it.
That's what I'm assuming. That's what they've done that.
Okay, so you should get 800 plus 100A equals 1200 plus 60A. The A's together should make 40 A's, and the numbers together make 400. So I should add 10 more liters of antifreeze. I should add 10 more liters of antifreeze in here. So tell me this. What would we have of antifreeze altogether now? How many liters? 18. And how much fluid do I have altogether now also? 30. Oh, let's try. 18 out of 30 is 0.6, 60%. Okay, so here's always the strategy. Your starting chemical, whatever it is, chemical, antifreeze, could be different things, plus add chemical. And then we did, what did we do here? The start fluid plus the add fluid equals whatever you're trying to get to, right? That's going to be the format. We started with something, we added something. We started with fluid, we added fluid. Okay, here's the one thing you might see. What if I started with pure water? That's how I started this drink this morning. It just had pure water in it, nothing else. So what's the starting chemical number if you have pure water? So sometimes I start with pure water and then I add to make it strong with something. Okay?